perfect cubes. A number is a perfect cube if you can find its exact cube root. A perfect cube is a number that can be written as the cube or raised to the third power of another number. This is what it would look like if you're taking the cube root of a number. You have the radical sign and the radicand, as we had before, in square roots. And then you have the new number 3, which is called the index. And this tells you that it is the cube root. And here are the perfect cubes. You have 1 to the third power, 2 to the third power, and so on. And that's how you'll find all of your perfect cubes. And then you're going to make a table. Put all of the perfect cubes all the way down to 10. So you can pause this and finish the table. Example 1, we have the cube root of 64. If you look at your table, the answer is 4, and it is because 4 to the third power equals 64. Example 2 is cube root of negative 216. And with square roots, you can't have that. But with cube roots, it is okay because you can take a negative number and multiply it 3 times to get the negative square root of 216. Here is example 3. The cube root of 64 over 125. You're going to do this the same way as we did perfect squares. You're going to take the cube root of the numerator and the cube root of the denominator, and you would get 4/5. And that is the answer because 4/5 cubed equals 64 over 125. Example 4. Now we have a question. Is 216 a perfect cube? 216 is a perfect cube because 6 to the third power is 216. Here is example 5. Is 504 a perfect cube? 504 is not on your perfect cubes table, so you would say no, because you can't cube any number to get the 504. Example 6. X cubed equals 27. Now we have an equation, and we have to do the opposite to both sides to solve for x. I'm going to rewrite the question, and because I'm cubing the x, the opposite of that is cube rooting. So I'm going to do the cube root of both sides, and just like square rooting, this cube root radical cancels out this 3, and you're left with x equals. So your final answer is x equals 3. 4. Example 7, x cubed equals negative 64. I'm going to rewrite it so I can show my work. And it's x cubed, so I'm going to take the cube root of both sides. This radical and 3 cancel each other out. And then once you take the cube root of negative 64, because you can do that, you would have x equals negative 4. Example 8. The cube root of m equals 9. Let's rewrite the question, and then because we're taking the cube root of m, the inverse operation would be cubing both sides. And again, the cube root radical cancels out the 3, and now you just have to cube 9. So m equals 729. Example 9, the cube root of x equals negative 7. Rewrite the problem so that you can show your work. Cube root of x, so we would cube both sides, sorry about that. And you would have this canceling, And you're left with x equals negative 7 cubed would be x equals negative 343.